Okay, this video is our second method of solving systems of linear equations, which is called the substitution method. Now, I'm not going to lie, it might seem a little intimidating at first, okay? But just like some other things we've done this year, once you kind of get the pattern down, get in that rhythm of what you need to do here, it actually ends up being not so bad. So just stick with it, practice it, and give it a chance. And I think in the end, it'll not be as overwhelming as it might seem like it is in the beginning, okay? So the substitution method is really good in certain scenarios, okay? When you have at least one equation that has x by itself or y by itself. So at least one equation is x equals something or y equals something, okay? Or if you don't have an equation that is x equals something or y equals something, you may be able to kind of rearrange one of your equations pretty easily to make it look like x equals or y equals something. So I'm going to say, or you can rearrange one. Okay. If you're looking at your system and you're like, yeah, I can't really get x or y by itself pretty easily here, okay, substitution method probably isn't the best method, okay, to use. Okay, what also really helps, okay, if you're not sure if you can rearrange it, a lot of times if you see coefficients of 1 or -1 in front of your x's or y's, okay, that's how you know you could probably rearrange it pretty easily. Okay, it's not always just 1 or -1. You could have, even numbers too, and it could still work out okay. But definitely coefficients of 1 or -1, you can rearrange it pretty easily to make this into a substitution worthy method. Okay, so we have example 1. Y equals 5 and 2x plus y equals 17. The idea with substitution method is we're going to take one of the equations and substitute it in, plug it into the other equation. Okay, we're going to start off kind of basic and get harder as we go. So with the first one, if y equals 5, I'm going to take that and I'm going to plug it in into the y in the other equation. So that 5 is getting plugged in right there. Okay, also, if you need highlighters, if you need to draw these arrows, whatever you need to do visually to see what you need to do, that is fine. Okay, so we're taking that 5, that y equals, and plugging it in for the y in the other equation. So that becomes 2x plus 5, because we plugged it in, equals 17. And if you have substituted correctly, you should no longer have an equation that has two different variables in it. And that means that we can solve for whatever variable that we have left. Due to lack of space, I'm not going to show every single step, okay? But it's still just our normal equation solving skills here. So first I would subtract my 5 from both sides. I get 2x equals 12 because 17 minus 5 is 12. And then I would divide both sides by 2 and get x equals 6. But remember, our answer should be ordered pairs. So x equals 6 is half the battle, okay? But we also need to know what the y is. But luckily, this question was a pretty easy one. If I'm going to write my answer as an ordered pair, my x is going to be 6, so it's going to look like 6 comma something. And if we go back to the original equations, which had y equals 5, guess what? That means our y coordinate of our answer has to be 5. So our answer to this system is 6, 5. Okay, I'm not going to go through and show the checks, but keep in mind, whenever you solve a system, you can always take that x and y and plug it back into your equations and make sure it does actually work. Okay, example 2, we have x equals 3y and 3x plus y equals -40. So I have x equals something, so this is substitution. So I'm going to take that 3y, that x equals, but I'm plugging it in for the x in the equation this time. So this 3y is getting plugged in right there. And when I plug it in, keep in mind, if it's 3x, I need to show in some fashion, whether by a dot or some parentheses, that 3 that was in front of the x is now going to be multiplied by the 3y, which we are plugging in for the x. So 3 times 3y plus y equals negative 40, which means really this is 9y plus y equals negative 40, because we did 3 times 3y. We can combine our like terms on that side. So 10y equals negative 40. And then divide both sides by 10. We get y equals negative 4. Okay, so we know our answer is going to have a y coordinate of negative 4. But this one's not as easy as the other one where we just knew the x coordinate already because one of the equations told us. But what we can do is take that y that we just got and plug it in. Now, technically, it does not matter what equation you plug it into, but especially with the substitution method, okay, there's usually one equation that's easier to plug into than the other. And that's the one that like had that x by itself already, okay? So I'm going to take my original equation of x equals 3y. I'm going to take my negative 4 that I just got, and now that's getting plugged in for the y over there. And I'm going to do a little more color coordinating. So my y equals negative 4 is getting plugged in for the y right there. And 3 times negative 4 means our x value is negative 12. So final answer is negative 12, negative 4. Okay, I could have also plugged that negative 4 into that 3x plus y equals negative 40, but then you're sitting there solving another two-step equation, and you don't want to do that if you don't have to. Okay, so whatever is easier to plug it into that one. Okay, the next one, y equals 5x minus 1 and y equals 2x plus 11. Okay, this is starting to look a little scary, but once again, they are not that bad, I promise. So over here, they actually both have y equals. Okay, so you can think about this two ways. You can say, hey, if 5x minus 1 equals y and 2x plus 11 equals y, then this stuff must equal that stuff. And that's your equation. Okay, or you can kind of go through the process like we've been doing and say kind of, well, my first equation, I'm just going to take that stuff since that's what y equals and plug it in for the y in that equation over there. Either way, our equation ends up looking like, I'm taking that whole thing, our equation ends up looking like 5x minus 1 equals 2x plus 11. Okay, so variables on both sides here, I have to get them to the same side. So I would start by subtracting 2x. I'm going to write super small on this one. So we get 3x minus 1 equals 11. We would add 1 to both sides. So we get 3x equals 12. And then we divide by 3, and we get x equals 4. And now we need to plug it in. Either equation here is pretty easy to plug it into. I'm going to use my y equals 2x plus 11. Okay, but 5x minus 1 would have also been pretty easy. And I'm going to take that 4 that my x equals and plug it in for the x over there. Lots of arrows. So y equals 2 times 4 plus 11. Y equals 8 plus 11, which means y is 19. So final answer, write it as our ordered pair, is 4, 19. Okay. Example 4, we're getting through these. Y equals 3x plus 2 and x plus 2y equals 11. So over here, I have my y equals, very nice. Now there is multiple things on this side. So we're going to be plugging in that entire 3x plus 2. Okay, and that is getting plugged in for the y on this side. So because y equals 3x plus 2, we're taking all this stuff and plugging it in for the y in the other equation. But we're going to have to be careful because there's a 2 in front of that y. So we have x plus 2. And now I'm taking that 3x plus 2 and plugging it in for that y. I need to make sure I am putting that 3x plus 2 in parentheses, because that is going to remind us that when we now go to solve for x, we need to distribute. So when we distribute, we get x plus 6x plus 4. Notice, once again, I want to note, when I substituted, I only ended up with x's. I don't have x's and y's anymore. Okay, so when you substitute, you should only end up with one variable. So we distribute x plus 6x plus 4 equals 11. I can combine my like terms together to get 7x plus 4 equals 11. I'm going to subtract my 4 from both sides to get 7x equals 7. And divide by 7, x equals 1. And we got one of the coordinates, but now we have to plug it in to get the other one. And I'm going to plug it in to that easier one in my opinion, which is y equals 3x plus 2. Because my x is 1, and I'm going to plug it in for the 1 in that equation. So y equals 3 times 1 plus 2. And hopefully we can see that y equals 5. So final ordered pair is 1, 5. Okay, last one. We have x minus 2y equals negative 6, 4x plus 6y equals 4. Unfortunately, in this last example, neither one of our equations looks like x equals or y equals. However, I do have this x, okay, that has a coefficient of 1 that I could pretty easily get by itself. So that's my first goal here, okay? I am first going to say, let's get x by itself, okay? And to do that, I would add 2y to both sides. Now, I know this is not putting it into slope-intercept form. Okay, slope-intercept form is specifically y equals, but we are allowed to manipulate any equation to do what we want it to do. In this case, we want the x to be by itself. So we're going to say x equals, and it doesn't matter which way we write it. We can say negative 6 plus 2y. I'm going to write it as 2y minus 6. Or I'll do this also, or x equals negative 6 plus 2y. It really doesn't matter because we're not putting it into any certain form. We're just getting the x by itself. Okay, I just think the 2y minus 6 looks a little nicer. Okay, because once again, look for those coefficients of 1 or negative 1. That's always a good indication that that is a good variable to get by itself. And now I have x equal to 2y minus 6. I'm going to plug it in for my x in my other equation. Remember, I'm taking this entire thing and plugging it in for the variable. So when we do that, we have to include the 4. And it's going to be 4 times in parentheses 2y minus 6. We still have the plus 6y, and we still have the plus 4. And if we distribute, we get 8y minus 24 plus 6y equals 4. I can combine my like terms together, so that gives me 14y minus 24 equals 4. Remember, when they're on the same side, no inverse operations, just, combine them together. To get rid of our minus 24, we add 24 to both sides, so it's 14y equals 28. And now divide both sides by 14, and y is 2. And now I do need to plug it in to find my x. Okay, once again, it does not matter which one we use. We could use x minus 2y equals negative 6. We could use 4x plus 6y equals 4. But I'm also going to use our first equation that we turned around. So I'm going to be using this part right here to plug it in. So x equals 2y minus 6 And I am taking what y equaled, sorry. Oops. That was not supposed to be a scribble. I'm taking what y equals, which is 2, and plugging it in for the y. My thing is on a delay. Plugging it in for the y over here. So x equals 2 times 2 minus 6. That'd be 4 minus 6, which means x equals -2. And our final answer is x was -2, so -2, comma 2. Okay, so once again, you are taking one equation where it's x equals or y equals and plugging it in for that variable in the other equation, which will allow you to find the other variable essentially. And then you can plug things back into equations to find the other one that you are missing. Okay, use those colors, use those arrows. Okay, I promise you, you can do this.